Welcome you all to the third day of the challenge. As the challenge briefs it, for this third day, we'll be looking inward we'll be continuing from where we stopped in the second day. In the second day of the challenge, we stopped at forming table of the recency table, the frequency table, and the monetary table, which we name it the frequency as an RFM based table, which is here. I can simply run this to see what we have in there. This is where we stopped in the second challenge. However, for today, we'll continue from here by segmenting. We'll start our segmentation today, segmenting the customers. Segmenting the customer basically into 5 segments. And those 5 segments includes, we have the champion. Champion here means our best customer. That is those customers that are really paying for our products in terms of monetary aspects. They're also frequently visiting our website and buying some things from there. And likewise, in terms of recency, they're also current. So they are best customers, that is, they are VIPs. Then the second segment that we'll be doing today is loyal customer. Loyal customers. Loyal customers are consistently good, but not up to, as in compared to champions. They too, they're also buying goods, but they are just like the second tier of our customer segmentation or our customer segments. Then the third, they are potential loyalists. Potential loyalists. Their own position also is not up to champion, and it's not also up to the loyal customer, but they are the third rank of our customers. They are trying to, as in, they are customers, but they are getting there to be our loyal customer, but not fully. Then finally, or second to the last, at risk. These at risk, those are those customers that you are doubting whether they might drop us, that is, they might churn, by the way. Then finally, those are the, as in, we have the hibernating customers. Hibernating here, just like system, that is, they are inactive. Their recency is very high, as in their recency is very high in the sense that, let's say they visited us like 2 years ago, and their frequency, let's say maybe just very few, maybe once, and their monetary aspect might also be once. So those are those hibernating customers, that is, those customers that they are inactive. So let's go back to our MySQL query. For the query today, I'll be posting it inside the chat box, so we can simply just, as in, follow along with that. Let me simply copy it here. Here's it over here. Control-C. So we can simply copy the query. It's right there in the chat box. So here is our MySQL interface, workbench interface. So for us to achieve this first part, that is, we want to try to segment our customers based on their recency, their frequency, and their monetary aspects. This first query over here, its function basically score our customers. It scores our customers based on their frequency, their recency, and their monetary aspects on a scale of 1 to 5. And 1 denotes worst, while 5 denotes best. Let's take, for instance, when we have a customer based on recency and frequency classification or segmentation, RFM. As you know, for us to have the best of our customers, their recency must be low. That is, they must come just of recent, they must visit our websites recently, And the frequency in which whenever they come, they are buying has to be high. And likewise, the goods or the product they are buying in terms of monetary wise has to also be high. That's when we achieve champion customers, that is the VIPs themselves. So we want to score them on a scale of 1 to 5. We'll be using a window function to achieve that, to segment those customers both based on their recency, frequency, and monetary wise. So from this database, RFM base, that is the table that we just created, that we created yesterday, this table, we are selecting the visitor ID, recency days, frequency, and let me comment this out first so that we can visualize the table. The frequency, the monetary. So this end time function over here simply splits all customer into 5 groups. Then over order by recency days in descending order. This particularly, this window over here is sorting our customer based on the days in which they bought our goods. And higher number of days means what? Who can answer to that question? If you have higher numbers of recency days, what does that mean? What does that mean?
It means that you visited the site frequently.
Higher number.
No,
Recently.
it means that they visited the site recently,
I mean,
and
if
therefore
let's take for
more
instance,
people visited it
okay,
recently.
recency days. If recency day is very high, let's say my recency day is, let's say, 300 days ago. What does that mean? Based on what we
Okay,
discussed
Likely to shun.
This is a long time ago you visited the
a
site.
long time ago.
Oh,
Thank you
yeah.
so much. So meaning that whenever we have an higher number of days ago, this particular line will class it as what? As worse. So people who bought, let's say, a long time ago, they might get a score of 1. And people who bought most frequently, as in most recently, I mean, not frequency here, most recently, they are likely to get a number of what? They are likely to be scored 5. That's what this line of as in query is really doing. And the next line over here is the frequency frequency line. Frequency, as we said earlier on, that it must be high for that customer to be good, right? And this, we are sorting it in this window function in ascending order. That is, people who bought less frequently get a lower score. Somebody that usually, let's say, somebody that bought our goods just only once or twice, we can't compare that same fellow with another customer that bought our products 10 times. The frequency of that fellow or that customer that bought our products 10 times is higher. So people who bought more often get an higher score of 5. Right? And people who bought as in our goods lower, they have that lower score of 1. Please, is that clear, please?
Yes.
All right. So the last one over here, which is the monetary aspects, I think this one will be more clearer to us because everyone as in loves money. So customer who spend lower or who spends less gets lower score of 1, while customers that spend more, they have that higher score of what? They have that better score of what? Of 5. So that is what this line of code, as in line of query, is really doing. So let us simply run our query and see what we have. Control Enter. So this is it. This was our RFM base table that we did yesterday. Visitor ID, recency days, frequency, monetary. But this R score, F score, M score, that's our newly segmented columns or segmented feeds. 3 here has a meaning, which I assume that we've understood it, what it means for the recency. Compared to 2, customer that have a recency score of 3 and customer that have a recency score of 2, are they the same? A question.
Not the same.
They are not the same. What are the what are their differences? Or just in a sentence, what is the difference between a customer that have an R score of 3, like this first customer over here, and this second customer over here, and 2?
It means that the one that has recency of 2, but more recent than the one that has recency score of 3.
From these recency days, I think it's will give us a clue on what these 2 and 3 means. Look at this customer that has recency of 2. Let me zoom out a bit. Okay, oops. I can't really zoom out the table, but let me just clean this. All right. Can you all see my screen clearly?
Yes, we can.
Okay. Yeah. Coming back to this customer of a thing. Yeah. This first customer over here with 716, like that, his recency is what 219 days ago when he visited our website. Why the second customer with this visitor ID over here? He visited our website 167 days ago. Obviously, 119 is lesser than 167, meaning that this guy over here visited our website more recently compared to this other guy over here, 167, right? That's why this R score for this guy over here is higher than what? Than that of this other guy that has 2. Just because this, as in this guy over here, this visitor over here, visited our website more recently compared to this other guy. Take for instance, if you have another lower number, low as in lower to this 119, let's take for instance like 53 over here. Can we all see these parts of the query? You will discover that the R score is 5, because what we are trying to do here for recency is that we want to minimize the recency as much as possible. Any customers that came very recent, will classify them as what? Good customer. That means that they are not that as in far from our website or far from our platform, our e-commerce platform, compared to somebody that that visited our website years ago, as in 100 of days ago. All those, as in all those kind of customer, all those set group of customers, there is high probability that they've forgotten us. So that's what that serves. Then, so the next, we've grouped our customer now based on the R score, the F score, and the M score. So we can simply save that into a view so that whenever we need it, we can simply recall the view. So let me uncomment this. This creates or replace view RFM score as this. What this particular line of the query is doing is creating a view. And as we know, view is quite different from a table. A view is just like a virtual table that records the queries alone. View doesn't store data. To create the view for this particular table over here. So we'll run this now. Control Enter. Let's refresh. As you can see, views here, there's nothing there before, but when we refresh that, we'll see that there is a new view over here, which is what our RFM scored view. Please, is that clear?
Yes, sir.
All right. So we can move on to the next.
Yes.
All right. Thank you. So we can now move on to the next parts of the segmentation. This first query has helped us to have our R score, F score, and M score in ranges of 1 to 5. But interpreting that will be somehow it won't be somehow comfortable. Imagine you are presenting your findings to the stakeholders and you are saying, okay, if a customer is in between this, it will have 5, it will have 4. Numbers, it won't be easier for us as human being for us to process numbers as fast as possible. We are different in terms of our computing capacity. Some are not that convenient with numbers. Whenever they are hearing numbers, they'll be somehow afraid of, or their understanding is very low regarding numbers. So you have to segment it based on what you know that whenever you're presenting it to the stakeholder, they will understand better. Coming to the next query over here, let me comment out the view first. So here we'll be using some SQL functions like concat and case when. Case when in MySQL is just like our if-else statements in Python. From RFM's code, that is this part of the query, this one that I highlighted, right? Can you see it? RFM's code. What is our RFM code? Which table is that? Is it a table or a view?
A view.
It's a view that we just created now, right? So we want to use that view in our query. So from this RFM scored view, select the visitor ID, the recency days, the frequency, the monetary, the R score, F score, and M score. That is all the table itself. You know, this is what all as in these are those features or the fees in the view as in view that we created. Let me just as in bring it down. Here is it as we can see over here. Visitor ID, recency days, frequency, monetary, R score, and the likes. That's what our view entails. So we're bringing everything out. Then afterward, we want to use the concat function. Concatenation is just what adding two variable together. Variable in the sense that it can be number with a text or string. It can also be, let's say, decimal with string, but just joining them together. Concatenation function what joins variables together in MySQL or in SQL generally. So what we are planning to do here is that we want to achieve something like this. We want to achieve something like this. Since we have the R score, the F score, and the M score. Let's say this is 5, this is 3, and this is 1. So we want to have another table that will combine the 3 together. That is R, F, and M using hyphen in between. This like this, after using concatenation function, it will result to something like this: 5, 3, 1. It has a reason why we are doing this. So that whenever we're using our if-else statement, that is our case when statement, we're able to segment these customers. That any customer that have this kind of as an habit, it should be classed under, let's say, champion, or it should be classed under, let's say, loyal customer and the likes. Please, are we clear with that as in that line of query?
Yes, sir.
All right. So that's what this particular line of query is doing there. So afterward, since we said we want to classify, we want to group these customers based on as in scores of 5 to 1, right? What will be the condition? We'll have to declare some conditional as in statements that, okay, whenever a customer have this R score of this, call that particular customer a champion. Whenever it has this particular RFM score of this, call that customer a loyal customer. So that's what this case when statement here will be doing. Case when R score is 5, and that's a logical statement. F score is 5, and M score is 5. Whenever a customer meets these 3 criteria or 3 criteria, right, it should display champion. For any customer that have R score of 5, that is their recency is very low, as lowest as possible, and their F score is very high, their frequency, likewise their money is very high, M score is also very high. Those kind of customer, they are what they are champion for them to have 5, 5, 5 all through. However, when their R score is greater than or equals to 4, that is 4 and 5, and their F score is also greater than or equals to 4, and their M score is greater than or equals to 4, those ones are what they are loyal customers. They did not meet that first category of being champion of 5 all through, 5 parallel, but they also have that potential of what of getting there, right? But we classify them as what loyal customer because their R score is what's in between 4 and 5. Likewise, their F score and their M score. Are we together, please?
Yes, sir.
All right. Likewise, the R score, as in for another condition that we want to make for this table is that whenever the R score is greater than 3, that is between 3, 4, and 5, and the F score also greater than 3, meaning between 3, 4, and 5. This time around, we are not as in including the M score as into it, just because this set of people, their M score definitely is 3 downward. Their M score is not up to what's up to 4. Likewise, it's not up to 5. So for all this kind of people, will be what they should they will be categorized or they will be segmented under potential customers. They are potential loyalists to our platform. Then finally, for any customer that their R score is less than or equals to 2, less than or equals to, that means it's starting from 2 to 1, right? Very low. Or that is very high numbers of these differences, as in they have very high recency. Because whenever a customer have recency of 1, that means they visited our website very long time ago, right? So the F score for this customer, if it's greater than or equals 3, that is 3, 4, 5, even though they are our old time customer, but they still, as in during their, as in being old timers, they still buy some things from our website of as often, right? So all this kind of customer should be classified as at risk. Then finally, if any customer doesn't meet these conditions that we've declared, you should declare them as what? Hibernating. So those are this, especially these customers, we don't need as in to spend money on them. End these statements and attributes the alias segment to it. So let us simply run this and see what we'll have. Control Enter. All right. Can we all see these parts of the table? Let me zoom it out. So as you can see, this is our, from this visitor ID down to M score, it's our RFM scored table. Then we attach this RFM score with the concatenation function. That's what is doing here. This concatenation function here. Concat, where is it? Yeah, this guy over here. Concat R score, iPhone F score, iPhone M score. As you can see, 3, 5, and 1. 3, iPhone 5, iPhone 1. 2, 4, and 1. 2, iPhone 4, iPhone 1, like that. So then based on this conditional statement that we gave using case and when function, we can see that it has segmented it, that this particular customer that has combination of RFM score of 3, 5, and 1, they are potential loyalists. And how do we define our potential loyalists? Those ones are what? Those customers that are trying, they are imagine from being just a potential loyalist towards to a full-time customer, loyal customer to our business. And see this customer over here, 2, 4, and 1, it's at risk of leaving, as in leaving us. So definitely, whenever we are targeting, let's say a promo or a discount, we'll target all these customers with what? With all those stuffs, with those discounts, with those promo, because they are liable to churn and won't want them to leave us. Definitely we'll try to as in personalize their emails. They'll be reflecting something like discounts, discounted products, promo for them, like that. So let's also save this particular table as a view. So for us to save that as view, we'll create the view table for that. Create or replace view. That's what this particular line of query is doing. Somebody speaking, please. So we can simply create the view of this table. Let's simply just run that, Control Enter, and let's refresh this. As you can see now, we have two views: the RFM scored view and what's the RFM segment view. Underneath it, we have this segment part. So we are done with MySQL part of what's as in of the analysis. Now, the next thing now is to this view and this is our table. We want to connect them to our Power BI. For us to achieve that, we need a connector that will connect our Power BI with MySQL. That is, we want to connect our Power BI, which is our visualization tool, to MySQL, or our MySQL to Power BI. That is so that they can be communicating to and fro. Let's say any data that we update, whenever we update, let's say any record here, it will reflect in the visualization in the Power BI. And whenever whenever Power BI needs something from MySQL, it will also able to also get it from MySQL. So for us to do that, we need a connector that will connect these two together. The connector we'll be using here is ODBC connector. we'll be using the ODBC connector. So for us to download that one, here is a link that I'll be pasting in the chat box for us to download the ODBC connector. Let's see. This site, MySQL download. Let me just paste it here. So we can simply save that for downloading of the MySQL connector. But whenever you log into that website, you see something like this. This first as in Windows x86 64-bit of a thing. That's the simply download this first one, 19.3 MB. And after you've downloaded it, you install it. After the installation, let me simply as an install mine. As you can see over here, here is it. Next, accept the terms and condition. Next, then just leave it as is, it's as typical as default. Next, then install. And that's all. After you've installed it, then come to your search bar over here on your Windows. As you can see, this ODBC data source, you can type it out, ODBC. Whenever you type ODBC, you will find out that you have one of 64 bits and one of 32 bits. This is the one we're working with. Our system majorly is what 64 bits bar. So we'll click on it. As you can see this as in this dialog box, click on add. Click on add. We are adding this MySQL ODBC 9.1 Unicode finish. Whenever you click that finish, it will bring a pop-up, another dialogs box that says data source name, the server, the root, the password. What this means, this data source name, what it means is that whenever you are using your MySQL or any SQL flavor you are using, you will initiate a connection, right? And you save it with a name. In our SQL, let me go back to home. This is the connection I initiated, my SQL connection. This is the default one. This is the one that we are using to practice our queries and the likes, where our database, our Google merchandise database is stored and everything. So this is the connection. The name here is Prax. I just save it with a random name. So that's your database connection. So you fill that in. That is, this is Prax, Prax. Description, you can leave that one. Then this TCP IP server, we are connecting these ports, these 3306 ports to our local host. You can simply type it local host. Exactly. Then this user, the user, if you did not tamper with your MySQL as a default setting, it's usually root. That's by default. When you are installing your MySQL, you'll be required to enter a default password, right? The password you use when you are configuring your MySQL, when you're setting up your workbench, you enter it here. Let me simply enter mine. So that's it. Then you can simply test the connection, whether it's as in connecting or not. Click on test. Test. Oops. It's denied this user using this password. This. Okay. Let me adjust that. Instead of me using this local host, let me just use the default host like this one. Okay, 127.0.0.1. Let me try that one out. 127.0.0.1, something like this. Let's test this. Okay, 0.01 rather, instead of 0.0.1. Dot 0.1. It's the same, pretty the same. Let's test it. Connection field with this 127.0.0.1. Let me check it.
Yes, I can see it.
Okay, I'm coming. Copy connection to stream board. Let's see. So we're using over here. Okay, let me see. All right, now it's correct. I think I'm making a mistake in my password. Sometimes, let me just as in clear this. Sometimes, as in whenever you are connecting to this TCP IP server, if you type localhost as I did earlier on, and it's true as in return some error, replace it with this default port, this localhost port 127.0.0.1. Then make sure that your password is also correct. You can simply test this, and now you can see that the connection is successful. Are we on the same page, please? Then here, this database, the database we are using here is the Google merchandise database. Click on it, then click OK. Then you can click OK. Also, as you can see, this is the connection we just make. Click OK, and that's all. Now you can simply go to your Power BI and connect to that particular connection that you've made between MySQL and Power BI. So let's head on to our Power BI interface. Here's our Power BI. Create a new blank report. Then afterward, let me cancel this. Afterward, click on Get Data. Can we all see this, please?
Yes, we can.
All right. So Get Data. Then click on this More over here. Now we are connecting our Power BI with ODBC connector, ODBC. As we can see, this is it over here. Click on it and connect. So from here, you see a drop-down menu. This is the prax that we just configured now, as in that's the connection we initiated. Click on OK. And here is asking that how do you want to connect with this particular ODBC driver with our username and password. Our username here is what? Root by default, and our password is that password that we connected for our MySQL database when we are configuring it. Simply enter it and connect. Wait a little bit for the connection to initiate. As we can see, this is our Google merchandise database, our information schema, MySQL. All these ones are just by default on the system, but this is the database we created. Let us simply just as in open the drop-down menu. These first two tables are the views that we just created, the RFM scored and the RFM segments. While these others are what our tables. This was the table we created. These are the tables we created yesterday. The staging transactions, RFM recency, RFM frequency monitoring, and RFM base, right? For this, our visualization that we'll be doing here today, we only need this RFM segment view and this our staging view. You can see that it has displayed here as in just like a display of that, and we can see that it's intact and it's in line with what we saw in our MySQL, right? Likewise, this staging transaction, we'll click on that. We'll be needing it also. There we have this our country, transaction ID, transaction dates, and the likes. So we are using these two tables, a table and a view, right, for our visualization. Then load them to your as inside your inside your Power BI. It might take some time, but just as in wait behind. So that's where we're stopping for today. Tomorrow we'll be continuing from Power BI, and mind you, today also, let me just as in before, lest I forget, we'll also be doing our wireframing. What do you understand by wireframing? Can any one of us just guide us through? We are talking about wireframing. So these are the table. Can we all see this data panel? These are the tables. So we've imported them successfully. Storage mode import. Then we can see this guy over here also, the staging transaction. We've imported it successfully. So we can perform any as in visualization operation on that. So can somebody just guide us on what wireframing is all about? Wireframing. Okay.
I want to try. I don't really know much about
give
it.
it a try, please.
Okay. It's like a layout of how our reports, the flow of our reports on Power BI dashboard.
Totally correct. Just the layout, just
Yes,
like
sir.
a sketch, a rough sketch. Okay, so not the real dashboard, but it's just like the flow, how it will go, the workflow, or the as individual flow of the dashboard itself, not the real dashboard itself. Imagine, let's say this is our dashboard.
Yes, sir.
This will be our, let's say, this is our Canva. Oops. So let's assume that for this our dashboard is just a brainstorming session. You can design your dashboard as in your workflow or your wireframe as you like. But no matter how you are designing it, you have to take into cognizance that anything you are displaying, any metrics you are displaying, it must be what key metrics that has something to do with what we are doing, the RFM analysis itself. Mine wireframe will be quite different from yours because as in our mode of thinking, they are different, even though we are still as in targeting same goal, but our mode of approaching it might be quite different. I might put let's say this is a dashboard, for instance. This is the as in Canva of the dash as in of our Power BI. Then let's say we have our key KPIs here. Let's say this one is KPI 1. Let me just as in divide it like this. Let's say we have something like this. The design goes like this. Don't mind my drawing. Let's say we have KPI 1 and another KPI over here, KPI 2, another KPI here, let's say KPI 3. Then let's say this particular side, this left pane of my dashboard is just for filters alone. I'm leaving all these one for filters. Then the filters, I can filter this table. Since I have country, I can filter it based on country. I can also filter it based on segments. You know, we have segments now. Inside the view that we just created, that's all this champion, loyalists, and the likes. So we can also filter it based on the segments. We can also filter it based on dates, if you like. You can add a date slicer over there. So all this left pane will just be what filter. I can design my website like that. As in, I say my websites. I can design my dashboard like that. Then coming to the main body, I can try to have some segments. Let's say I just only have, let's say in order not to make it cluttered, let's say I will only have 3 segments here. That is, this is my first segment 1 of my dashboard, segment 2 and segment 3. These 4 segments here, I can simply say, okay, what I want it to be, it's just like a behavioral breakdown of what I want to display. What does this English means? It means, let's say, I just want to display the segment distribution. You know, we have champion, loyalist, and everything. I can simply just display a bar chart for that, displaying something like this. That's okay. This is the number of champions we have in our data set. Then followed by, let's say, the loyalist. Then followed by, let's say, iChon, as in iChon, our at-risk customer. And also, let's say we have hibernating customer over here like this. So that gives us a behavioral overview of the segment distribution. That's okay. Let's take, for instance, we have, I'm just assuming, as in I'm not sure with the result that we'll get. Let's say for this particular analysis, we have a very high at-risk customer. That visual will tell the stakeholder to know how to channel their campaign very well on all these at risk. That is, there are many customers that are ready to leave you. So definitely you must know how to retain them with all, as in by every good means that you know that you can acquire them back. You must put it into play. Then let's take, for instance, we are followed by champion, meaning that our business is still doing good. We have some champions that are then hibernating customer, they are not that much. We can simply just as in circle them out. So I can just put some behavioral breakdown here, like bar chart of the segments over here. Then I can still have, let's say, a clustered column. That is a clustered column like this. Something like this. based on, let's say, frequency, recency, and monetary. Let's say this is for recency, frequency, and monetary. I can have it also beside this place. I can have, let's say, a clustered column here also on my, as in on my dashboard. Then let's say for this second pane of my, as a main pane, I can put this as a let's say a geographical detail. I can include my geographical detail because you have country, right? Geographical details. There are many visuals you can use for geographical details to demonstrate that. You can use map. You can use map. I can just simply put a map over here, maybe a word map that will indicate the areas in which our segments they concentrate, the country in which they concentrate. I can have a map of a country. Then I will color it based on, let's say, the total revenue and based on the numbers of the customers, right? Then beside it, I can also have, let's say, maybe a table over here like this. The table will just comprise the visitor, what the visitor is, the details about the visitor and the likes like that. So I can leave it like this in order not to clutter my dashboard or my flow. I can just stop at 2, something like this. And I can put, let's say, maybe the website of our, as in the logo of our e-commerce platform over here. So what I've illustrated here is just what is called wireframing. Just a rough sketch before executing it on Power BI itself, before starting as in dragging and dropping anything over here. You can also stop in here for today. If there's any question, we can simply as in bring it up regarding what we've done today. Then regarding the first tax, we'll also speak about that, as in second tax, I mean, we'll also speak about that after questions. Any question, please? So tomorrow we'll be starting as in the dashboarding process itself. We'll complete that. Then the next, which is the 5th day, we'll complete our Git and GitHub. Then we'll also as in discuss how to put this inside your portfolio, how to as in present it using Star framework and the likes. Is there any question, please?
So my only question is that I have XAMPP. Are you saying that my SQL rather?
Yeah.
I'm using XAMPP. Are you saying that we
Okay.
cannot use
XAMPP, XAMPP, its function is quite different here. XAMPP, basically, they usually use it for website development, right? It has MySQL, Apache, PHP. I think that X, I've forgotten what that X denotes, but it's just like an acronym for all those things that are inside, right? Here, the MySQL we are using here is basically designed as a desktop MySQL version. You can Dockerize it, but this one we are using the basic one. You can use that MySQL inside an app. That one, that MySQL inside that app is basically designed for any app or any web you are developing. Whenever any data that's as in the front end of your website will be stored internally inside that MySQL. You can use it as we are using it with Workbench here, that you are visualizing things and everything like that over here. That is only meant for web development. But this one that we are using here, you use it for all this as in our data analysis of a thing. There you are, you have your model parts, you have everything there that you can simply leverage on. Is that clear?
Yes, but
all right.
It's actually the PHP I'm using under the XAMPP. Like
Okay, you are
almost
using PHP to as in
yes.
to access your MySQL, but
Yes.
so however, if it is convenient for you in doing so, you can continue. Yeah, you can use PHP. You can also use Workbench as your user interface.
Okay.
All right. You're welcome.
Will I be able to connect my Power BI to it?
Actually, I can't guarantee that. I don't know actually, but you can research on that. But the one that I'm very clear of is as in connecting Workbench with MySQL using ODBC connector, like we just demonstrated now. I'm very sure of that. But connecting PHP to Power BI, Actually, I don't have the knowledge of that, but you can research on that actually. So any other question, please?
Okay, sir. My question is based on yesterday task.
Okay.
I find it difficult to carry out that ingestion, loading my data. So in order to meet up with the time, I just find a way, go on YouTube, watch some video. So I was able to bring in my data sets using another
Oh,
method. Is it
okay.
acceptable?
It's acceptable. It's acceptable. You know, yesterday when I was discussing this part of the query, I made mention of it that this is just a simplest method of what of importing your data. You can connect to a MySQL, as in you can connect your data source to your MySQL database using different method. You exploring another different method, it's a knowledge gain. You know that you can use this method, and if it doesn't work, you can also what maneuver it with another method. It's acceptable. You'll be scored for that.
Okay, sir.
All right. And then, okay, somebody has a question.
For that, you were talking when you were talking about the code of that view. There was a code about view, this. You mentioned two things, view and something. I didn't really get
View
the
and table.
yeah, view and what?
And table in SQL. There's difference between view and there's difference between table. A view is just like a virtual table, but not written, not stored. The data is not stored inside the view. Take for instance, let me just illustrate that one before we leave. Let's say these are database. There are some tables inside. All these table, there will be a space that will be allocated to them. A physical storage space. Let's say this is like 3 kilobytes, this is 4 kilobytes, everything, let's say sum together, the total sum of the table here, let's say is just only 10 MB, for instance. But view is not like that. You can't see it. It won't be inside, as in you can't trace it out physically. The only thing that view usually saw as in store is the query. View stores query, but table store both what table stores data, the data itself. Take for instance, like the view that we created. Let's say for instance, we tampered with the data that is in the table itself that we created the view from. You know, we created this particular view as in this RFM scored view from what RFM base, right? RFM base is our table, while RFM score is our view. Let's say we tampered with this base, which is a table that encompasses, as in that include our data inside, right? This view won't work because it's depending on this. It won't work. The only thing that view stores is what is the query. Why the data itself, the main data is still what is still inside this table. That's why they do call it virtual table. Is that clear, please?
Yes,
all right. Thank you so much. So let's simply call it a day over here, and we'll meet tomorrow. Tomorrow we'll start with our dashboarding process, and we'll complete that tomorrow. Then afterward, we'll move on with our portfolio, how to as in structure this particular project in a portfolio that will be as in professional and well organized in as in a standard data analysis analyst portfolio. So we'll be discussing that in the 5th day. So let's call it a day. Tomorrow, see you guys tomorrow. Thank you for attending. Have a good night.
Thank you very much, sir. Good night, sir.
thank you.
Thank you, sir. Good night.